So we're going to examine a series of ideal gas laws, and in its most fundamental form or explanation, it's basically the relationship between three main variables or quantities, one of them being pressure, another being volume, and finally we have temperature. So the three laws will examine these variables under different conditions. Now, in terms of analysis, if you look at the graph, you will see exactly what is happening here based off of the law that we just discussed, where pressure is inversely proportional to volume. So what that means, as one value increases, the other will decrease. So let's say we pick this point on the graph right here, then you will see as we go along in this direction, volume is increasing, and as we go up, pressure is increasing. So the further we go along the line here, the horizontal for volume, you will also see that the lower we are on that axis, that vertical axis for pressure. So therefore the two quantities here are inversely proportional. You will come across this term called isothermal process, and all it means, whichever one of the terms you see iso, it means that that's fixed, and thermal, temperature, so fixed temperature or constant temperature in this case. So let's look at an analysis or a few analyses so we can wrap our heads around the use and the purpose of this law here. So let's say we have some gas that occupies an initial volume, so V1 of, let's say, 0.1 cubic meters. So that's the initial volume. And let's assume it's pressure, so let's take P1 to be 1.8 megapascals to represent pressure. Now, for some reason, we decide to change its volume, so we're going to amend its volume. So this is V2 now. We're going to make that a bit smaller, let's say to 0.06 cubic meters. Typical question is, what's going to be the new pressure? Now, you will find the calculations to be relatively straightforward, but a bigger problem usually is how to know which ones to apply, which I'm going to explain that as well. So we would use our formula. So in our formula, we have our P1, V1. So this will be P1 times V1. So P1 is 1.8 megapascals. Don't need to really change the unit to times 10 to the 6 because the answer that we get will be in megapascals. Our volume is already known, so our volume is 0.10 for the initial volume. And then what's changed is the final volume, so we don't know P2, and the final volume is now changed to 0.06. So what is going to be our new pressure then? So what we need to do here, as you can see, we just simply need to divide what we have here on the left by our 0.06. So if we do 1.8 multiplied by 0.10 and all divided by 0.06, then our new pressure is going to turn out to be 3 megapascals. And that's in line with the theory. So you can see here where we have this volume that we started off with as 0.10, but then we compressed that gas. So all of a sudden, the space for our atoms to move around is much smaller, so they are bouncing off each other at a much more rapid pace than they were in the bigger container. So they are generating a lot more heat energy, which is why the pressure will be building up. So this here is logical and in line with what we expect. So let's look at another condition then. So let's now say we have some initial pressure in our system. So we know what P1 is, in other words, and P1 is, let's say 1.8 megapascals again. And we know the initial volume as well, which we're going to use our 0.10 cubic meters. And we now change our pressure for some reason to 2.4 megapascal, and we need to now find out what that new volume is in proportion or in relation to that change in pressure. Now, right away, the first thing I would want you to anticipate is what will happen to the new volume. So you can just look at the graph and basically tell. So if we're moving from the pressure of 1.8, so say we're here on the graph at 1.8 megapascal, and we now increase that pressure. So let's say we're now here. What would you expect to happen to the volume? So that's something to just consider ahead of the calculation. So let's input our known values. So we have 1.8 megapascal for the initial pressure, multiplied by 0.1 for the initial volume. We now know our final pressure to be 2.4 megapascal, and we do not know our final volume. So of course we can see where we just need to divide our total here on the left by 2.4, and when we do that, 1.8 times by 0.1 and divide by our 2.4, then we expect that the volume would be decreasing. So hopefully you've figured that out. So 0.075 cubic meters is our final volume, which is in line with our expectations, as this volume is smaller than what we started off with. So hope that gives you a clear understanding as to what Boyle's law represents, what it's all about, and we're going to take this next step further and look at another ideal gas law, and the next one that we examine will be Charles's law. So just click this video in the top right and we'll have a look at that.